Now, the first concept we're going to be looking at is Pythagoras' theorem. Now, this is a way of solving the lengths of different sides of a right-angled triangle. And there's a few things we need to establish just before we get right into it, is that we need to understand the side opposite the right angle in a right-angled triangle is called the hypotenuse. It is the longest side. So, if we have just here our right angle, opposite our right angle, the opposite side is the hypotenuse, and it is the longest side. The reason being, this is the largest angle, this 90 degrees. These two angles can only add up to 90 because the interiors angles of a triangle have to add up to 180. So if this is 90 and this has to be 90 between them, they have to be split, these can not project a bigger side. Hence, this is always 90 and the side opposite it will be the largest side, and it's called the hypotenuse. Now, another thing, Pythagoras' theorem says that the square of the length of the hypotenuse, so if we get this length and square it, is equal to the sum of the squares of the lengths of the other two sides. Okay, so before we just dive into this really quickly, what it's saying there is if we get this length, okay, how many centimeters that is, and we were to square that number, okay, that number is just depicted by a letter, which is C, but if we were to square that number, it would equal this side squared and this side squared plus together, okay, and we're going to look at that and why that makes sense in a second. So we end up with this theorem, okay, if you're writing it down in your books, which you should be, you need to put a big red box around it because this is very important. The hypotenuse squared, the longest side squared, equals the two shorter sides squared. Now, let's go into a bit of depth as to why that is true. Okay, here we have a right angle triangle here, okay, with the sides C, A, and B. And C is the hypotenuse because opposite the right angle. So this just here in red is our longest side. We also have our two shorter sides, A and B. Okay? Now, what we've done is we have actually created squares based on all of those sides. So these aren't rectangles, they're squares. And you're going to say, well, if this length here is A, I'm going to make this side A. So these are the same lengths. And if we're trying to find the area of that square, to find the area, you're going to times the base times the height, and that's going to give you area squared. So A squared for this square. Now, if we're looking at B, this side is B, this length is B, the area would be B squared. And lastly, if this side is C and this side is C, because it's a square, we multiply them, we're going to get C squared. Okay? So we've got these lengths, and now we've squared them all, and we've got these kind of square shapes. Well, what if we were to break these two up to form a different shape, like a bigger square? So if we were to take this square and pop it in the middle, and then we were to get this square and break it up into 4 triangles, we have got a shape that is exactly the same shape and exactly the same area. So we could say that this area, this C squared, just here, matches the two areas of the other two sides squared. Okay? So what this proves is that, we don't need to do this all the time, but this is just an introduction, that the longest side here, C squared, equals this side squared and this side squared plus together. Because we're plussing this blue and this green to make this shape, and it equals the same size as our red shape. So, before we start doing examples, these are Pythagorean triads. It is a set of whole number triangles that can be used to form right angle triangles. Best known examples. Okay, these just keep appearing over and over again. These are right angle triangles that we can prove that Pythagoras' theorem is true, but these are used for whole numbers, so they kind of work very well. Let's just take this one for instance. This side, this 5, is opposite our right angle, so this must be our hypotenuse. Okay, so our c squared, our c, and let's just say this one is our a and this one is our b for base. So if we write Pythagoras' theorem, which is c squared equals a squared plus b squared, we go, okay, well what is our c? Our c is 5, so let's put this in. 5 squared equals a squared, which is 3 squared, plus our b squared, which is 4 squared. And if we put these together, 5 times 5 is 25, 3 times 3 is 9, plus 4 times 4 is 16. Okay, let's see if this is true. 9 plus 16, does that equal 25? Yes, it does. 25 equals 25. So this tells us, yes, that is true. That is true. So this must be true. This must be a right angle triangle. Oh, I've drawn this a little bit much. Let's do some questions. Now, with this exercise, you are just solving for the hypotenuse. So this is actually very easy, this exercise. You're going to be squaring these two numbers, plussing them together, and then finding the square root. You are just doing those 3 operations over and over again. Okay, it is not difficult at all. So, if we have this is our c, our hypotenuse, because it's opposite our right angle. Then we have our 12, which is our b, 5, which is our a. Let's write out Pythagoras' theorem. C squared equals a squared plus b squared. What is our a length? That is 5, so let's replace this a with 5. 5 squared. And our b is 12, so 12 squared replaces b. Let's figure out them. 5 times 5 is 25. 12 times 12 is 144. If we plus those together, we get 169. And if we square root 169, that should be 13. Yes, 13. So let's do this again. Whoops. C squared. Now, this is still c squared. The reason why we want to square root is because we want to find out what c is, not c squared. Well, this is not the final answer. Okay? So, we've squared both numbers, we've plussed them together. The last step is we have to square root to figure out what c is. Because if we have a number that's squared and we square root it, that gives us our original number. So this now changes to c. Okay? It's like if we have a number, we times it by 2 and then divide by 2, we have our original number. If we square a number, then square root it, it goes back to its original number. So it's c. And the square root of 169 is 13. And we should probably say c equals 13 units, because it's a length. We don't know if it's centimeters, we don't know if it's meters, we don't know if it's millimeters, but we do know it's a length, so we should say it's a unit. Okay. Now for this one, we have to find 2 decimal places. So let's do that. Let's start off. Let's say this is our b. B is always our horizontal line, and this is our a, and this is our c. So we'll start off by writing Pythagoras' theorem. C squared equals a squared plus b squared. Let's fill in our a. So that's 7 squared plus 9.5 squared. And let's figure those out. 7 times 7 is 49. And 9.5 squared equals 90.25. Let's plus them together. 139.25. Now remember, this is still c squared. To get it to c, I need to square root both sides. So let's do that. C will equal square root answer 11.80. Okay, and units. So that is our answer for that one. Now, the next little one, find the length of the hypotenuse in this right angle triangle, leaving your answer in exact value. Now, exact value means you will leave it in with the square root around it. Now, just to look back why we would do that, this answer are whole numbers, so that's 100% accurate. This one, we had to round to decimal places. So even though it does have a level of accuracy to 2 decimal places, we have still cut off the rest of it, which was all this. Okay? And even though they're very small numbers, if we're dealing with something very precise, those numbers would count. So what some questions want you to do is they still want you to have that level of accuracy by leaving it in exact form. Therefore, it's every number that can't be square rooted perfectly is still maintaining its level of accuracy. So, let's do this. C squared, this is our A, this is our B, A squared plus B squared, so always writing our theorem first. Our A is 2 squared plus B, which is 5 squared. 4 squared, 2 times 2 is 4. 5 times 5 is 25. Put those together is 29. So our C squared equals 29. Now, if we want to find out C, we square root both sides. This will give us C equals the square root of 29. Now, you do not want to change that answer. That is your answer. It might seem incomplete, but that is an exact value. If we were to put that in our calculator, square root of 29, and it was 5, and we rounded it to 2 decimal places, that would round up to 5.39, and then the rest of this would be cut off. Okay, we do not want to do that. We want to leave it like this. Okay, even though it's ugly and it feels like it should be operated on with the square root, we have to leave it because that is 100% accurate compared to this answer, which we would round.